Hello guys, today we are going to solve one of the Leetcode problem. This is a very interesting problem. Let's quickly jump to the description of it. So basically this is a shifting letters. So you are given a string and you have been given a shifts array. This array is representing a start index, end index and the direction, right? And direction, if the direction value is 1, then we have to move forward. We have to shift the character in the forward direction. If the direction is 0, we have to shift the characters in the S in the backward direction. Shifting a character forward means replacing it with the next letter, right? So if you are at Z, right, you will be you have to shift at A because that's where the wrapping around property is also included. And if there is also the backward case, if you are at A and if you have to move by one character, right? So you would be landing at a Z, right? So let's quickly see this example. This ABC, this is the string is given, and we have to shift by the shift queries are also given, right? We have to shift this string. Now, if we go one by one of this query, so what it is telling from 0 to 1, we have to move backward. 0 means backward, right? So A will become Z and B will become A, right? 0 to 1 and C will be as it is. So 1 to 1, what it is telling from 1 to 2, we have to shift the character in the forward direction. So Z will be at it is and A will be B, C will be D, right? Now if you see this one, right, 0 to 1. So it means from 0 to 2, we have to move by one character. So, I mean, we have to shift the character by one. So A will be, so Z will be A, B will be C, and D will be E. So I hope you would have got the idea of this problem, what we need to do. So let's see how we are going to solve it, right? So one way that you take individual queries and then you identify that, I mean, go from left to right and shift the character based on the given condition, right? Just to make a note, this uh, and and index is also included, right? This is given in the question. So and is inclusive. So if we are taking individual query and we are solving it, this is going to be, I mean, this will definitely is one of the solution, but this is not the efficient solution. The reason is what happens if every query is having start and end index equal to the length of string. Then you would be end up for every query, if the size of S is n, you would be end up n times for individual query. And if there are n queries, the time complexity would be n square. So is there any better solution? Yes. So there is a algorithm called ScanLine algorithm, and it will help you to solve this kind of problem into O(n) time. So let's see how this ScanLine algorithm works, right? So let me quickly explain the scanline algorithm and then we'll apply that algorithm into this problem. So what scanline algorithm says, so if you have, let's say this array, right? Array size of 3 just for the simplicity, right? And you have the query arrays, right? For now I'm going to take this. So what I'm saying is from start index to end index, I have to increment the value by 1. From start index to end index, I have to increment the value by 1. For simplicity, I'm just, taking only the positive case, right? So if we are going with the brute force approach, what would be the value, right? So 0 to 1, we have to increment 1. So this will become 1, this will become 1, and this will be 0. This is our first query. After second query, what will happen? 1 to 2, we have to increment 1. So 1 will be as it is. At first position, this will be increment to 2, and at second position also it will be increment to 1, right? So this is our answer. But this is the brute force approach. What is scan line algorithm says, right? It says don't iterate over the given indexes, right? Only two step is required. at the L position, right? At the L position, what you do, you increment the given, you increment the index by the given value, right? So L is 0, right? Let me just clearly write it, right? So at L position, you increment the value, whatever the value is there, by plus 1, okay? And at R plus 1, what is R? Basically, let me call it out. So this is R, L, and this is R. So end position I am referring as a R. So at R plus 1, whatever you are adding, right, just subtract that value. And if you're subtracting at R plus 1, add that value. So just do the opposite of it, right? These two steps we have to do. Now let's see that how it will save our time complexity. So when the first query we are looking at, our array will, at L position, this will become 1. Um, this will be as it is, right? This will be 0. But at R plus 1, right? At R plus 1, what will happen? This is 0, right? There we will have to do a minus 1, right? Just the opposite of it. This is our first query. In the second query, what will happen? What it is telling at L position, increment 1, right? This will be as it is. And 2 plus 1. So 2 plus 1, 3. 3, third index is not there because we have only 0, 1, 2 index, right? So we don't need to do anything. So this will be like this one, right? Now after that, do the prefix of it. So this will be 1, 2, 1, right? This will be our prefix. Now compare this value with this value. These both are same, right? And in the scanline algorithm, what we are doing, we are just updating two indexes for every query. We are not iterating from left to right, right? That is the part where it is giving you a better time complexity, right? So you are just iterating over the query and you are able to find the output of it. The same algorithm we are going to apply into this problem. Let's see how we are going to apply it. So let's say we have this 0, um, 0 and 0, right? The length of S is 3. So we'll create one array with the 4 size. Okay, let me call it temp. Okay, now we'll take this individual queries. So it is telling from 0 to 1, we have to go in minus direction. So at 0, we will just do a minus 1, right? Because it is telling to do go in the minus direction. So we'll do minus 1. We don't need to touch this one, right? But at 1 plus 2, and this is 0th index, 1, second, and third index, right? So what at the R plus 1 we have to do? At the second index, we have to do the opposite of it. So we'll add one value, right? And rest of the thing will be same. This is after query 1. Now after query 2, how it will be look like? At the L position. What is L? This is our L position. We have to increment the value. And this will be as it is, right? This will be as it is, and 2 plus 3, right? So 2 plus 3 is this part, right? There we have to decrement the value because when we are incrementing the value here, we will decrement there. This is after query 3. After, sorry, query 2. After, so for the query 3, what will happen? From 0 to 2, we have to increment, right, by 1. So at 0 position, we'll just add. So this will become 0. Okay. And this will be as it is, right? This will be as it is. And at here, it will be 0. Okay. Now do the prefix of it. So this will be 0. This will be 1. This will be 2. Okay. Now if you see, right, this is our S that was given. This was the S was given, right? After this shift, our position would be look like the A would be shift by 0. So this will be A. Let me just write it A, B, C. So A will be shift by 0, so A will be this one. B will be shift by 1, so this will become C. And C will be shift by 2, so this will become E. And this is what our answer is, right? This is what our answer is, ACE. So what exactly it is doing? It is combining every shift, right? After n query, it is finding the final shift that you have to make on the S. And once we find out, we have to just shift the character by accordingly. So let's quickly jump to the, the coding of this problem that what we have discussed till now. Let me clear it out. So let me say that my length of S is n, okay? And let me have one temporary array that would be the size of 0, okay? And this will be of n plus 1. Okay, the n plus 1, again I'm just reiterating. The reason is, see, the maximum index is possible is 2, right? The length in the length of S, but we have to do some operation in R plus 1, right? So I don't want to put a lot of if condition to check whether R plus 1 is going beyond the index or not. I'm just adding one extra index for that. And let me say that for L, R, and the direction is there in the shifts, right? So I'm going to iterate over the shifts to form my final shift array that will be there in the temp, right? So if direction is, 1, if that is the case, so what will happen? The L part we have to increment by 1, but in the R plus 1 we have to do the opposite of it, right? And just do the opposite of it. If the direction is given and we have to do in the opposite direction, the L will be minus 1, okay? And temp R plus 1 will be plus 1. Once that is there, now we have to the third step is to find the prefix sums array, right? So that we can find the answer. So for that, I am just going to use one variable. What I will do is I will have this answer string where I will store all the answer, and I can iterate over my this temp variable. But you remember the temp variable we created one extra. So the last we are not going to consider the last value of the temp because that is just an extra value we have created, right? So our range is only going to be till n. Now in here, what will happen? I will form my prefix sum. So this current is going to act as a prefix sum, right? So from the temp, I will store this value into current, and I will find my form my final position of the character, right? So how can I can form my final position? So you remember the odd thing is there, which will give you the index of a particular character. So I'm going to find this index. First, I need to, find the proper index in terms of 26, right? The 26 range. So, and every character is in lowercase. So I will do this, and whatever the value of this is there, I will just add it. Okay. Let me add it basically here in plus current. And then there is going to be a wraparound property, right? So total 26 letters are there. So I will do the wraparound. Now in answer, I can just add it. So once this final position, final index of a particular character, I get it. I just need to change into the character, right? So what I can do is using chr function, I can take this index, I can add 97 to finally map to a proper lowercase letter. See, here we are converting it. I mean, here what we are doing, we are doing minus 97. So we are, from 0 to 26, we are forming this array. And then we are adding the proper, the final prefix sums array, right? For a particular index, which is the final position, which is telling where the character is going to shift, whether in the right direction or in the left direction. We are just adding it, and then we are doing the wraparound part. Okay, I hope this makes sense to you guys. um, then what happens is, again adding 97, right? Or I can simply copy this one as well, so both are same. So once the character is added, that's all what I have to return. So I can return the answer. And that's all for this code. Let's quickly test it and verify. Um, Unsupported string to integer. Oh, actually the bracket. Okay, this should be fine. Yeah. So let me quickly submit it and verify it if it is correct. Yeah. So you can see how faster this algorithm is, right? So that's all for today, guys. Let me know if you have any problem or confusion. Just do comment in the comment box. Thank you.